Hello guys, my name is Raven, and today we will be having a tutorial about calculator techniques in differential calculus. First, we will discuss this list. We'll go over three problems: limits, derivatives, second derivatives, curvature, third derivative, partial derivative, implicit derivative, slope, parametric equations, maxima and minima, and then lastly, related rates. Let's go first with the limits of a function. Example number 1. Evaluate the limit of this function as x approaches to 0. What we're going to do is, by the way, all these calculator techniques will work on 991 Casio ES, Casio 99570 ES, and other models as well. It will also work on Karce 991 and also work on some Canon, I think. I don't know. So first, we will evaluate this function as limit x approaches to 0. What we're going to do is go to mode 1, type our function, then we use calc. We'll approach the function in both sides of 0. First, the negative side, the left side, approach it by negative 0.0001. That would be a very small number, 5 x 10 negative 5. Then we approach it to the other side, which is the positive side, positive 0.0001. That would be 5. That would be 5 x 10 negative 5. So what if we try to approach it even closer to 0? That will be approaching to 0 as well. If it's in the negative, still 0. Therefore, our answer would probably be 0. Next problem. Let's take let's say example number 4. So evaluate this. Okay. So we're going to do that same problem again. Same method. Type the function sine 1 over x. Alright. Press calc. Approach both sides, negative 0, left side of 0, and then right side of 0. So 0.001. Okay. So that is 0.9. Okay. Next, positive right side of 0. Okay. Negative 0.9. So they're both close to 1, but different polarity. So that means it's probably does not exist. So let's check. It does not exist. Alright, answer is does not exist. Okay. Next problem. This problem. Evaluate limit this function and then as x approaches to infinity. So we're just going to type the function minus 4x. Okay, press calc. So since it is approaching infinity, we're just going to type a really large number, 9999. So the answer is 0.4. Try again, larger number. It's still 0.4. Therefore, one of these, C or B. 2 over 7, let's check. 2 over 7 is 0.2, 3 over 7 is 0.4. So the answer is B. Okay, next. Now we're going to move to the different topic, different derivatives of functions. So, y. So, we get the derivative of this. We just type it in our calculator. 3 minus 2x squared. Alright. We put it inside the derivative. And then, we're just going to put the value of x as 0.1 unless it is stated here, but it does not stated that the value of x has a value, so we just put 0.1. So the answer is negative 0.11. 0. That number. Okay, so that's the answer. That's the constant value. So let's check in the choices. We will manually try all of these problems, and then until we get the correct answer, the same value. So we're going to skip. We're going to try letter C. Okay, let's try letter C. Letter C is, I'm just going to type it, negative square root 3 minus 2x squared. Okay, calc, same number, 0.1. So the answer is negative 0.11, which is the same number as we computed earlier. Therefore, the answer is C. Problem. Okay. Okay. How about if we try this problem? Find the derivative of h with respect to u if h is equal to pi raised to 2u. Okay. So, same method. We're just going to type the h, pi raised to 2u, let's say x. Okay. Put it in the derivative function, and then we're going to type 0.1 since there's no given value. 0.1 equals, so 2.8. That's the constant value. So we're going to try all of the choices if it will be the same value. So we're going to try letter A, 2 pi raised to 2u ln of pi. Okay, let's check. Okay, it's the same value, therefore it is the correct answer. Next problem. For our third example in derivatives, differentiate this function. So what we're just going to do is shift this function and then arc sine 4x squared, 4x squared. Okay, and then 0.1 as our assuming value. Then the constant number will be 3.59. So let's say we're going to try the answer B. So let's just type the answer B. Sine 4x, then 1 minus 16x squared. Just going to press calc. 0.1 equals, then 3.59, 3.59. Therefore, this is the correct answer. Okay. Next problem. Okay. For our third topic is how do we get the second derivative of a function. So, first example, find the y prime of y equals to x ln of x. So, we're just going to type this in our calculator. X in our derivative function x ln of x, then assume value as x.1. Okay, then we will shift store to a. Okay, and then do that again, but for our x that will be plus 0.1, no, plus 1 times 10 raised to negative 3. Okay, equals shift store to b. Okay, then we will use this formula, b minus a over the increment we used. So that will be 1 times 10 raised to negative 3. So the answer is 9.9. 9.95. Okay, then we're going to try any of these choices until we will match the same value. So first, let's try letter A. Let's try letter A. Okay, 1 over x calc 0.1 equals, it's 10. So 9.95 is approximately equal to 10. Therefore, the answer is A. Next problem. So, okay, how about this? Find the second derivative of y equals to x plus 3 for x plus 2 quantity raised to 3 when x is equal to 1. Okay, we have a value of 1. So, we will just use the value of x as 1. Same process. Type the same function into the derivative function. 2x plus 3 for x plus 2 cube. Then we will use the value given to us, 1. Press equals, then we will shift store a. Then do that again, but however, add the increment, 1 times 10 raised to negative 3. Press equals, and then shift store b. So that's our b value. Then use the same formula, b minus a all over the increment, 1 times 10 raised to negative 3 equals. So remember this number, 7 to 8.76576. Okay, 7 to 8. Then, oh wait, 17. It's already the answer. Okay, this is the answer. So that's the answer. Okay, third problem. Okay. Next topic. Find the radius of curvature of the parabola y squared equals 4x at point 4,4. So we will use this formula. The radius of curvature is equal to this. Okay. So what we're going to do is just type our function in the same derivative. So we type it. So but first we will need to isolate y. So square root of this cancel, then it will be square root of this. So y is equal to square root of 4x. So we type that to our calculator, 4x. Okay, then our value of x is 4. So type it 4, then equals, so that value is 0.5. Shift store a, then try that again. but add the increment. Plus 1 times 10 raised to negative 3 equals, so approximately the same. Shift store B, then put it in the formula, B minus A all over increment 1 times 10 raised to negative 3. That is our constant value. So that is our value for our second derivative. And then we will apply the formula. 1 plus first derivative squared, then raised to 3 halves all over the second derivative. Okay. Shift store, let's say C. Let's say store to D as our double derivative. So we apply the same formula. 1 plus the first derivative. Our first derivative is shift is A. Okay. Then squared. And then is all raised to 3 halves all over the double derivative, absolute value of double derivative. Alpha D equals 22. So our final answer is 22.36. What's the answer? 22.36. So therefore this will be our answer. Okay. Next problem. Let's try this problem. Find the radius of curvature of the ellipse 3x plus y squared, 3x squared plus y squared plus equals 12 at this point. Okay, the same process. Type the function in the derivative, 3x squared plus y squared. Oops. However, as we have noticed, the y is not isolated. Therefore, we must isolate the y first. So this will be y squared equals 12 minus 3x squared. Then we root both sides. Then y is equal to 12 minus 3x squared. So we will type the modified function 3x squared. Okay, then our value of x is given, which is 1. So equals alpha store A. Oops, sorry. Equals shift store A, then do that again, add the increment, plus 1 times 10 raised to negative 3 equals shift store B, then we get the double derivative, B minus A all over the increment 1 times 10 raised to negative 3, then equals shift store double derivative into D. Okay, then we apply the formula. What's the formula? This is the formula. This is the formula. So curvature is 1 plus the first derivative, which is our A, and then squared, then quantity raised to 3 over, oops, raised to 3 over 2 all over the double derivative, absolute value of double derivative D. Okay, then press equals, we will get our answer 2.12. Where's 2.12? This is 2.12. That's our answer. Okay. Next, we will now tackle our next topic, which is how do we get the third derivative. So it is similar to the last topic, which is the second derivative, but extended. So first, we try this problem. Find the third derivative of y equals x ln of x. So we just type this function into our derivative function. So x ln of 0.1, then that will be our a. Okay. Do that again. Plus 1 times 10 raised to negative 3. That will be our b. Okay. And do that again one more time. Now add 2 increments, so that will be 2 equals, so shift store c, that will be our c. And then we will get the second derivative first. No, we don't need to say. And then we will apply this formula, this representing our c, b, b, and a, and this is our increment. Okay, let's try. So remember our c minus b all over increment 1 times 10 raised to negative 3 minus, remember the formula, b minus a all over increment, all over the increment. Okay, equals. So our answer will be 98. Okay, answer will be 98. So we will check in our examples the answer. Let's try the answer, letter B. So let's write this down first. Negative 98.03. Okay, let's try letter B. We're just going to type it. Negative 1 over x squared. Okay, calc as our increment 0.1, assuming value 0.1. So that will be negative 100. Negative 100 is very close to negative 98. Therefore, our answer will be B. Next problem. So let's try this problem. Find the third derivative of y equals this. Okay. So the same process. Shift, then find the derivative of this. Find the derivative of that. 2x plus 3, 4x plus 2 cube, assuming value of, no, our value of x is 1, so therefore we will put 1. So that is 1298. Shift start to a, then do that again. Add the increment 1 times 10 raised to negative 3. Calc. Yep. Then that will be our letter B. Shift store B. Okay. Then add another increment. So shift store, no, sorry. Equals, that's our letter C. Shift store C, then follow the formula. Remember the formula is C minus P all over increment minus B minus A all over increment all over increment. Okay, follow it. So C minus B all over increment b minus a all over increment all over increment. So our answer will be 1152. Check the choices. Therefore, our answer is this letter B. Okay. Next problem. Next topic. So our next topic is partial derivative. Okay, our next topic will be partial derivatives. Find the partial derivative with respect to x of the function this. So see, almost the same process. We type our function in our calcu. X y squared minus 5x plus 6. So we will assume values x as 0.1 or just press x. So 0.1, 0.2 as for the value of our y, then press equals, then this will be our value. Okay, so you write that down, negative 496.96. So we try our choices. Let's say our choice will be letter B. We'll type that in our calcu, y squared minus 5, press calc. Our y is 0.2 equals, so negative 4.96, which is the same value as we written down, therefore that this will be our answer. Okay, next problem. So given example number 4, given this very long question, we just type our function in our derivative function, x squared y minus 10 y squared. We will be assuming z as m cube plus 43x minus tan 4y, x as x, then we press calc. Our x will be 0.1, y 0.2, our m 0.3. Press equals, then our constant value will be 43. We write that down, 43.04. Then we try the choices. So let's try the answer A. We type that in our calcu, 2xy plus 43 calc, same 0.1, 0.2, and then 43.04, which is the same value as this. Therefore our answer will be A. Next problem. So example number 5. Find the same problem, but we will be derivative with respect to y. Okay, so the same problem, just type our problem in our problem. So however, what we're going to do in this problem is we will change all of our x into m and our z into c, and then our y will be x. Since our calculator is always differentiating with respect to x, so we're just going to change the variable y into x's. Okay, type the derivative function and then x squared, x is m, therefore m squared, then y is x. Okay, minus 10, y is x, therefore x squared z is c cube plus 43, x is m minus 7 tan 4x, then x as x, calc. So our m is 0.1, x is 0.2, then our c is 0.3. Will be 57. Okay, then let's say we chose the letter A as our answer. So we write that down, negative 57.78. So we try letter A, 2xy plus 43, press calc, equals press calc, x is 0.2, therefore this is not the correct answer. Next we will try letter B, x squared minus 20 y z is c, z is c, cube minus 28 secant squared. Secant squared is 1 over cosine then we press calc, 0.1, 0.2, 0.3, and 57. Therefore 57, therefore our answer will be letter B. Next problem. Okay, our next topic will be implicit differentiation. Implicit differentiation is wherein we try to get the derivative of the function, however, of our equation. However, our equation is a mixture of both x and y variables. So if, however, our y can be isolated, we can transform it into explicit equation. We can then derive it normally like we have done it before. However, let's say our equation cannot be transformed into explicit. What we're going to do is we're going to solve for y, shift solve for y using x as 0.1 and y as 0.2. Oh no, just y is no need to add assumption of value. So what we're going to do here is find y prime from the function xy plus x minus 2y minus 1 equals 0. So to solve this function, solve this equation, is that we're just going to type it in our calculator, xy plus x minus 2y minus 1 equals 0. We add comma and y by pressing shift, then close parenthesis, then shift solve 0.1, and then press equals again. We shift store that into A. Okay. We do that again. xy plus x minus 2y minus 1 equals 0. Add comma. And y shift solve 0.1, and we add increment. Plus 1 times 10 raised to negative 3. And anything for y. We shift store that into b, shift store b, then you have b plus ac. We're going to follow this formula, b minus a, and then over increment, b minus a over increment, 1 times 10 is to negative 3. Then we'll have our answer 0.277. we take note of that. 0.77. Then let's say our answer is letter A, so we're going to try this choice. Press AC, just type that into our calcu. X minus 2, then press calc. X is 0.1, then compare. Our answer is the same number, therefore letter A will be our answer. Next problem. This. Find the y prime of the curve at a point this. So our x and y is already given, therefore we're just going to substitute it. So we type our equation, shift solve x cube y cube y fifth plus 3x equals 8y cube plus 1. So we add comma and y, shift solve. Our x is 0, our y is negative 0.5. Okay, so this will be our letter A. Shift store A, then we type all we type our equation again. X cube y fifth plus 3x equals 8y third plus 1 comma y, shift solve. X is 0 plus increment 0.1 times 10 raised to negative 3. Then our y is negative 0.5. Press equal, and then this is our answer. So shift store B, follow the formula, b minus a, all over increment 1 times 10 raised to negative 3.5. Therefore our answer is 0.5. However, as another alternate solution for these problems is that we're going to follow this formula. Y prime is equal to derivative of the function over, with respect to x, over all over derivative of the function with respect to y. Just going to try that. So we type this in our calculator. Derivative x cubed y fifth plus 3x but we isolate it, so we transfer this to the other side. Negative 8y cubed minus 1, x is x calc, x is 0 and y is negative 0.5. So this is our derivative with respect to x. So we store that, shift store into a. Okay, use that same equation again. However, this time around we're going to change all y into m and x, all y into x and then m of into x. Let me repeat. This time around we will change all y into x and then x's into m. Okay, just change everything, y into x and x into m, y into x and x into m. So equals, time out, great. Calc, m is 0.1, x is 0.2. Oh, sorry. Calc, m is 0, x is negative 0.5. So that's 6. So we shift store to b, then we apply the formula. This, remember, our a is our derivative with respect to x and b is derivative with respect to I. So add the negative a over b equal 0.5. Same answer, 0.5. Okay, next topic. Okay, so our next topic for differential calculus is application slope. First problems is that it's just taking the derivative of the function, so we're going to skip these, and the same problem here and the other problems as well. So we're going to skip to this problem 6. Given y equals x squared plus 3x, find the slope when x equals 3. So the slope is equal to the same formula we have been using before. So to find the slope, we're just going to find the y prime. So we're just going to derive this problem. X squared plus 3x. Put it in derivative function, x squared plus 3x, and then x is 3. So equals, and then our x, therefore our slope is 9. That's our answer. M is equal to 9. Next problem. The equation of the tangent line at x equal 3. Okay. So when we say the equation of the tangent line at x equal 3, what we're going to do is we're going to go to mode 5(1). We have two equations here. So to find the equation of the tangent line at x equal 3, you will use point slope form. Tangent line has slope of 9 prime equals 9. Okay. Solve for y when x is 3 to find the point. Substitute x equal 3 to the equation. So we're going to use the equation again. We're going to use the equation x squared plus 3x calc 3, that is 18. So we're just going to type that in mode 5(1). Now the c is always 1. Okay, the first one is the what we are given with, which is 3. Then B, you have solved 18, and then C is always 1. Then 3, always the first one plus 1, okay, plus 1. And then 18 plus what we have, plus the slope, plus 9. Okay, and then always 1. Then there we have it. Our x is equal to 1. X is equal to 1. And y equal to negative 1 over 9. Meaning, we will have this equation. 1x negative 1 over 9y equals 1. So we're going to cancel the 9 here. We're just going to multiply 9 here. Then we will have this answer. That's how we get the equation of the tangent line at x equal 3. Third problem. The equation of the normal line at x equal 3. What we're going to do here is, just like the last problem, what we're going to do is we will be using the negative reciprocal of our slope, meaning our slope is 9. What we will going to use is negative 1 over 9. Okay, then we will use the same method here, which is mode 5 1. Then type it in our calculator once more. So going back, 3, then 18, then 1, then 3, always plus 1, 3 plus 1, then 18 plus our negative reciprocal of our slope, which is 1 over 9. Okay, and then C always 1. Then we will have our answer. 165 for x, 3 over 55 for y. Then we will have this answer, 1 over 65x plus 3 over 55y. We'll try to cancel the 65 here, and then we will have this answer. Okay, next problem. Find the equation of the tangent line to the curve y equals of this function at its point of inflection. Point of inflection meaning that y double prime is equal to 0. As you can see that our example here, it does not have a given value of x. Unlike our last problem here, our given value of x is 3. However, in this problem, we don't have a given value. So what we are going to do is that we will manually derive this function here. We derive it. This is the first derivative, and then we derive again, and then we will equate this y prime into 0. 0 equals 6x minus 12. So we will solve. This is where we will get our value of x. We will be solving the value of x here, and then we will get the value of x here. Okay, so next is we proceed as we did last time here. Since our value now is equals to 2, let's do that again. First we will get the slope, type our function in our derivative function, x cubed minus 6 x squared plus 5x plus 2. Then our value of x is 2. Press equals. Our slope is 7. Then we will use that value into our mode 5.1. However, we will first get the value of b. We type our answer again, and then calc x is 2, so it is 4. Then we go to mode 5.1. We will type x is 2, then b is -4, c is always 1, then x is 2 again plus 1, then b is -4 plus -7, and always 1 for c. Okay, then press equals. You'll get 7/10 7/10 and equals again 1/10. We'll try to cancel the 10 here by multiplying the whole equation by 10. You will get this answer. 7x plus y equals 10. Check the choices. 7x let's try to rearrange our it's already rearranged here. Y is equals to 10 minus 7x. Y is equals to 10 minus 7x. Therefore, this is our answer. Okay. Our next topic for differential calculus is parametric equations. Find the slope of the curve whose parametric equation is given by y equals t squared and x equal this function, and when t is equal to 2. So the simple formula of using parametric equation, the slope of the curve would be this formula. So basically, we're just going to get the derivative of y with respect to t, derivative of x with respect to t. So I just type that in our calcu. Get the function, get the fraction, then get the derivative. So first the y, x squared, and t is equals to 2. Then again 3t minus 1 cos 2 equals 4/3. Therefore, our answer will be this. Next problem. Find the slope of the curve's parametric. Same process. Get the fraction, and then type our function of y into our numerator by the derivative. So x cubed plus x squared plus 1/t, and t is 0.5. X fourth plus 3x squared, then 0.5. Therefore, our answer is negative 9.14 over 14. There you go. That's it for parametric equations. So our next topic for differential calculus is maxima and minima. Our first problem is determine the value of x on interval this to find the minimum value on f of x. So we're just going to mode 7, type our function, then press equals, then start is -1, end is 4, step is 1. Okay, our minimum value, we're going to find the lowest value. Our lowest value is -11, so that will correspond to 2. So therefore our answer will be C, 2. Next, this one, the same problem. Okay, next problem is find the positive number that exceeds its square by the largest amount. So x that exceeds its square by the largest amount minus x squared must be a positive number. So we're just going to type this, x minus x squared 0 to, let's say, 10. So it doesn't work that way. I'm going to try this, x minus x squared, substitute value for our given answers. Let's try 1/3, 0.22. So 0.22, this is 0.22. Our next value is 1, 0. Then let's try 2, -2. I try 0.5. This one is 0.25. 0.25 is larger than 0.22, therefore our answer is D. Next problem. The sum of two possible positive numbers is 10. Find the minimum possible sum of the square of one and the cube of the other. So, given condition, the sum of two positive numbers is 10. Okay, x plus y equals 10. Okay, find the minimum possible sum of the square of one and the cube of the other. So we will find the minimum value sum with the square of one and the cube of the other. So we will use this function. However, this has two variables, x and y. So what we're going to do is transform this y into x variable. So we're going to pull that from our first equation. Therefore our y is 10 minus x. I'm going to substitute that here. Therefore s is equal to x squared plus 10 minus x cube. Okay, we will type this. We'll type that here and try to find the value, the minimum value, using our function mode. So we're gonna type that, x squared plus 10 minus x cube equals from 0 to 10, since two positive numbers is until 10. Step 1. Okay, so we're going to find the smallest minimum value. Our smallest value is 72. Therefore, that will correspond to x is equal to 8. However, there's no 72 here. So we will try to get to look closer into x is equal to 8. Try that again. However, we will start from 7 until 9, since the smallest value is 8. So let's check. 71. Okay. 71.87. Therefore, our answer is 71.45. Next problem. What is the maximum length of the perimeter if the hypotenuse of a right triangle is 5 meters long? So, right triangle, hypotenuse is given, and the perimeter is the sum of the 3 sides. Okay, perimeter is sum of the 3 sides. So we will use this equation to get the maximum length of the perimeter. However, this equation has more than one variable. Therefore, we will transform one variable into the other variable by using Pythagorean theorem and isolating one variable to transform into the other. So we will try that. We will use y is equal to this. So therefore, we will substitute that in here. Here, I mean. So we're going to type this in our calculator. X plus this 5 squared minus x squared plus 5. If essentially type this, then we will try to find the maximum length. So our step is we will start from 0 to 5, and our step is 1. So we have our list. Then let's look for the maximum length. There are 2 12s, 3 and 4. So therefore we will change the step 0 to 5. Change the step into 0.5. There is 12 and there is 12.07. That means you can choose letter B. Therefore this will be your answer. Okay, next problem. At 12 noon, ship B is 100 miles east of ship A. If ship B sails west at 10 miles per hour and ship A sails south at 12 miles per hour, when will the ship be closest to each other? We will have our diagram. This is supposedly ship A, and this is ship B. So ship A will be going down at the rate of ship A will be going down at 20 miles per hour, and ship B will be going to the center at 10 miles per hour. Okay, and when will be the closest? You will use the distance formula here, y being y squared. However, since ship B is already 100 miles east of ship A. Therefore, our x value will be 100 minus x. We're just going to type this in our calculator and then substitute the choices from the equations. And which one will be the smallest amount of distance will be the answer. Let's go back to mode 1. And then type our equation. However, we cannot use this equation. We will substitute what is given to us, which is this. Our problem A, that will be 1r, therefore 1 equals 92. This is our distance, 92 miles. Try again. Let's say 2 hours, 89 miles. 3 hours, 92 miles. 4 hours, 100 miles. Therefore, our smallest amount of distance will be B. Therefore, that will be our answer. This one is the same problem. Now we will try another problem. Okay. An open box is formed by cutting squares of equal sizes from the corners of a 24 by 15 inch piece of metal sheet and folding up the sides. Determine the size of the cutout that maximizes the volume of the box. Okay, imagine a metal sheet. We will cut squares outside at the edges of our box to make our box fold. Okay, after that we will determine the optimized squares that we will cut off to maximize the most amount of volume we can make by cutting squares around the metal sheet. Okay, so here, this is our metal sheet. So our volume, of course, length times width times height. Length will be length will be 24 minus 2x. Since there's an x here, there's an x here, that will be 2 x's. Therefore, and this is 24 inches. Therefore, 24 minus 2x. Okay. The width, this is 15. And there are also 2 x's. 1x here, 1x here. Therefore, 15 minus 2x. And the height. The height, when we fold this here, is just x. Therefore, x, going back to the formula of our volume, we will multiply all of this together. Then we will get this formula. We're just going to type that in our calcu. our equation. Just going to type this in our calculator, and then 24 minus 2x, 15 minus 2x, and then multiply all of it by x. This is the value of our volume. Then we will press calc and check which one of these has the most volume. First we will try 1. That's 286. Let's try 2. That's 440. 440. Let's try 3. 486. Let's try 4. That's 448. So, by comparing the 4 values, we see that the most amount of volume is letter C. Therefore, it is our final answer. Next, our final topic for this tutorial is application related rates. Example number 1. Boyle's law states that when a gas is compressed at constant temperature, the product of its pressure and volume remains constant. If the pressure of a gas is 80 pounds per square inch, then the volume is 40 inches cubed. Find the rate of change of pressure with respect to volume when volume is 20 inches cubed. Find the rate of change dP over with respect to volume dV. That's what we are going to find. So, quite simply, the product of pressure and volume is equal to K. Okay? And then, we can rearrange that, plug in our values, 80, 40, then we see multiply that and rearrange that equation, differentiate both sides, then you will get dP over dV, then also derivative this within our calcu. So we're just going to type that in our calcu. 3200 all over x when x is 20, because we are deriving with respect to volume, so we also use when volume is equal to 20. So that will be 8, and then we will multiply the answer. No, actually this is our answer. Our answer is -8. Okay, next problem, example number 2. If y is equal to x cubed and 4 plus 4x squared and dx over dt is equal to 3, compute the dy over dt when x is equal to 1. So what we're going to do is to differentiate y with respect to x when x is 1. We're going to find dy over dx first. When x is equal to 1. Now we have our dy over dx. We will get dy over dt. We will simply multiply the dx over dt, which is given here, 3. Multiply by 3. Our answer is 33. Therefore, our answer is 33. Next problem. A ladder is 20 feet long, is placed against a wall. The foot of the ladder begins to slide away from the wall at the rate of 20 feet per second. How fast is the top of the ladder sliding down the wall when the foot of the ladder is 12 feet from the wall? So, we're going to do here is simply Pythagorean theorem. So we know that our ladder is 20 feet long, leaning against the wall. This is our wall, this is 20. The foot of the ladder begins to slide away. Therefore, we will slide away from the wall at the rate of 2 feet per second. That is dx over dt is equal to 2 feet per second. Okay. How fast is the top of the ladder sliding down the wall when the foot of the ladder is 12 feet from the wall? So what we're going to find is dy over dt. Okay. You'll get dy over dt by using this formula. dy over dt is equal to dy over dx times dx over dt. Okay. So first, let's try to find dy over dx. Going back to the problem, our given is dx over dt equal to 2 feet per second. Here, dx over dt, 2 feet per second. And then find our dy over dt when x is equal to 12. So basically, we have our Pythagorean theorem, x squared plus y squared equal to the length of our ladder, which is the hypotenuse. So we rearrange it. Since we're trying to find the dy over dt or the y prime, we try to isolate y. Then we derivative this. Let's use our calculator. Square root of 400 minus x squared when x is equal to 12. We have this. Now that we have this, we will multiply it in our dx over dt. Our dx over dt is 2, so simply multiply 2. So therefore we will have negative 3 over 2, which is negative 1.5. Therefore our answer is negative 1.5. Next problem. Another similar problem. As fisherman has a fish at the end of his line which is being reeled at a rate of 12 feet per second from a bridge 30 feet above the water. At what speed is the fish moving through the water toward the bridge when the amount of line out is 50 feet? Assume the fish is at the surface of the water and there is no sag on it. So here are given again, which is dx over dt being reeled at the rate of dx over time divided dt. So dx over dt is equal to 2 feet per second again. And then bridge is 30 feet above the water. This is the bridge, then this is the water. This is 30 feet. At what speed is the fish moving through the water? So we're trying to find the speed at which the fish is approaching the bridge. That is given by y. However, that's only y. If we're trying to find the speed, we're going to have to find the dy over dt. Understood? Dy over dt. Okay. So how do we get that? A squared plus b squared is equal to c squared. However, our c squared is already given, which is 50 feet. So we just write our a squared 30 plus b squared, which is y, equals to c squared, which is x. X is 50. So rewrite this. 30 plus y squared is equal to x squared. But we will not directly substitute 50 because our constant value of x is equal to 50. So we're going to isolate our y again, y prime. Then we will differentiate this. dy over dt, dy over dx first. So we type that in our calculator. X squared minus 900. Our x is 50. So we have 1.25. However, this is only dy over dx. We want to find the dy over dt. When we're trying to find the dy over dt, we will simply multiply dy over dx to dx over dt. Our dx over dt is 2 feet per second. So we just simply multiply. Since the direction is going to the bridge to the left side, that will be negative 2. So our answer will be negative 2.5. That will be our answer. Let's skip some problems. Let's try this problem. Our water is being pumped into a conical tank at a rate of 100 cubic feet per minute. So that is volume over time. The volume over time, dt, 100 feet. The height of the tank is 20 feet. Height is 20. And the radius is 5 feet. How fast is the water level rising? Okay. So dh, which is height, when the water height is 50, height is 10 feet. So over dt. Trying to find dh over dt. Okay. So if we're trying to analyze this, problem visually, you can observe that ABC is very similar to ADE. So we can use our ratio and proportion. R over H is equal to 5 over 20. Radius over height is equal to 5 over 20. Our radius is 5. Our height is 20. So if we will substitute our smaller radius here, smaller height, which is 10, then we will also get the radius of the height of 10. Okay, our radius for the height of 20 is 5. So if we will want to have the height of, we want to have the radius of with the height of 10, we will simply use this equation. So move this height here, and then that will be R is equal to 5 over 20 H. And then if you want our height to be 10, 5 over 20 multiply to 10, that would be 2.5. Therefore, we now know that this radius is 2.5 radius if our height is 10. So why do we need the radius of this? We'll now move to mode 3, and then the x values will be our height, and then the y values will be our area. We just plug in our values, 0, then the next height is 10, and then the next height is 20. How do we get the area? So 0 height is also 0 area. 10, what's the radius? What's the area of a circle? The area of a circle is pi r squared. So therefore pi r squared. How do we know the radius corresponding to the height of 10? It is what we have computed, 2.5. So therefore 2.5 squared pi r squared equals, next, then we'll get the area of when height is 20. Our radius with the height of 20 is given, it is 5. Therefore pi r squared. Now we have our lists. We're going to press AC, shift, stat, regression, then go for Y. Now the question here is, how fast is the water level rising when the height is 10? Simply type 10y. We will have this. Now this is dv over dt. This is dv over dt. This answer is dv over dt. In order for us to this is dv over dh. In order for us to get the dh over dt, we will simply divide 100 by this number. Why divide 100? Because we observe that this area is dv over dh 19 point blah 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 from chain rule. To get the dh over dt, we will divide the dv over dt all over dv over dh. So our dv over dt is 100. So we type 100 divided by our dv over dh ans equals, that is our answer, 5. So 5.09, that is our answer. I hope you guys are keeping up. I hope I'm explaining it well. Next question, last question for today. A trough filled with water is 2 meters long and has a cross section with the shape of isosceles trapezoid, 30 centimeters wide at the bottom, 60 meters wide at the top, and a height of 50 centimeters. If the trough leaks water at a rate of 2000 cubic centimeters per minute, how fast is this water falling when the water is 20 centimeters deep? So you have this 2 meters long, 30 meters wide bottom, 60 meters at the top, a height of 50. Then at the trough leaks water at the rate of 2000 cubic meters. That's the rate. How fast is the water level falling when the water is 20 centimeters deep? So what we're going to do is what we did before, mode 3.3. So going to paste our heights at x and our area at y. So 0 height is equal to 30 times 200, 30 centimeters times 200, meaning that's 2 meters, equals then 25, because the average of 0 and 50 is 25. We're trying to compute the middle ground of 0 and 25. 0 and 50, that's 25. Next, what's the area? 45 times 200 meters, 200 centimeters. How did we get to 45? Because the average height of 30, which is the measurement at the bottom, and the height of the measurement at the top, we get the average of these two, and then we will get 45. Then multiply it by 2 meters. Then lastly, at the top, we will have 50 then 60 times 2 meters, then equals AC. Then what we're going to do is find dV over dH when x is equal to 20. So we will simply shift stat regression y, find the dV over dH when it is 20. Why 20? Because that is what is asking. 20 y hat equal 8,400. However, as we remember the chain rule, dV over dt all over dV over dH is equal to dH over dt. After getting dV over dH, we will divide this from dV over dt. Our dV over dt is Trollics water at a rate of 2,000 cubic centimeters per minute. So 2,000 negative 2,000 divided by our answer, that will be negative 0.238 as the fraction, that's negative 5 over 21. Negative 5 over 21. That is our answer. Okay guys, thank you for listening to this calculator techniques covering all topics of differential calculus. These are some sample problems. If you want to check, just pause. I don't know how to answer all of these, so bahala na kayo dyan. I'm just trying to teach so that I can learn by my own. These are the answers. Thank you for listening. Bye bye guys.